warm-ups will be from current slide. And before I'll even turn on the projector today if I can find there it is. All right. Huh? Jayla? Yeah, okay, got it. I know you're in here. There you are. Okay. Anyone else coming since I called drop? Okay. That's coming up. We've got projection today. One day, what was it, this week or last week, we could not get the projector to work, so I recorded only by sound. So sorry about that if anyone had to live through that. All right, there are a few announcements. I'll try to make them as brief as possible, but they are many. If any of you are interested in becoming Miss Lawson State or considering that, I would invite you to what do they call it? There's a session today, I think 11:30 to 1 or something like that, down in the testing room. I think it's 182 or something like that. Here's Krista. Okay. So if anyone's interested in that, you're welcome to go to that. They had one yesterday on the Birmingham campus. I left that sheet on my desk in the other classroom, so I don't know the exact deal with that. Now, this week is not one of my favorite weeks of all time, okay? And the reason is tomorrow is a wasted day, okay? All full-time faculty, except for nursing faculty, are required to go to Montgomery all day long, okay? And so if you have a class tomorrow with a full-time instructor, hopefully you've been in touch with that instructor and found out. Now, maybe there was some reason that instructor got out of this trip. If so, I want to know how. Okay, no, I'm just kidding. But there's the two, I mean, okay. All right. I doubt if they were able to, but if they were, like had a mini-term course or something like that, and they could not miss, then they may be having class. If you have an adjunct instructor for a class tomorrow, they should be meeting their classes, okay? But full-time instructors, just about every one of us are going to be on the way to Montgomery by this time tomorrow morning, okay? Well on the way to Montgomery by this time tomorrow morning. So, wasted day. Now, Thursday, okay, there's Honors and Awards Day, okay? That's going from 10 to around 12, maybe, yeah, around 12 or so, I would guess, okay? What does that mean? Classes are canceled. All classes, my understanding, are canceled from 9 until 12:30. So that means we will only meet for half an hour Thursday morning. Unless, of course, y'all want to come in at 8 and we can meet for a full hour before we have to go. What you say? Oh, I can't believe that. All right, I thought I'd give you all that opportunity to jump at it. Okay, so we'll only be meeting from 8:30 until 9. I may stretch a little past 9, but I've got to leave and go to the Birmingham campus. We're supposed to be there by 9:30, and because of that issue, it takes about 30 minutes to get there, so we'll have to end. So only be meeting from 8 to 8:30. Now, what we'll do after that meeting at 8, that time at 8:30, I will show you in the YouTube videos where to go to pick up the rest of that class, okay? And you'll be able to follow that. And the baseball guys here know how to do the videos. They've been doing them conscientiously, and they can tell you how to access those and take best advantage of them. Okay, so that's going on Thursday. Okay, so sorry about that. Now, they came out with a final exam schedule, and as far as I can tell, it's wrong, okay? Most of it's right, okay? But they have finals starting on Monday the 29th, whereas the academic calendar says they start Tuesday the 30th. I've emailed them back and said, look, this is not in compliance with the academic calendar. Something's wrong here, okay? So hopefully they'll get that corrected. How they'll correct it, I don't know. They'll screw it up. Now, here's one thing about the finals, and you need to know this, so spread the word. Whereas classes start at 8:30. We started this last fall, okay? So people could get kids to school and stuff like this. I don't know. There's a reason for it. But we used to start at 8. Now we start at 8:30. The final exam schedule still starts at 8. Makes no sense to me, okay? But if you have an 8:30 class, like this one, the final exam will be 8 o'clock, okay, not 8:30, okay? So all the finals will start on the hour, okay? So if you have an 8 or 8:30 class, it starts at 8 o'clock. If you have a 9 or 9:30 class, that starts at 9 o'clock, okay? Now, this is probably going to be changed, but the even-houred classes, they are one day a week, and the odd-houred classes are on another day. So it'll be Monday, Wednesday, or Tuesday, Thursday, okay? So those will be, that's how those will be running, okay? So, okay. I think that's all you need to know now. So hopefully they'll get that changed. They also have on here, another error they have, all grades for M2 and regular term students must be input into the website. This is for us, not for you. Website suite system no later than 12 noon on Monday, May 8th. Well, May 8th is Wednesday, okay, not Monday, okay? And even the, welcome. On this page, the third page, it says Wednesday, May 8th. So I assume it is Wednesday, but it's just sort of all screwed up. All right, the Harmon brothers are here. Cole and Ryan. Good deal. Is there anyone who I've not acknowledged you when you came in, or you did not call your name at some point? All right. Those are most of the announcers. There may be others, but anyway, let's move on. All right, we're in Chapter 2. That's polynomial and rational functions. We are almost through with polynomials. We'll soon be on rational, hopefully today. And we're on example 10 in your book, 9 on the slide set. They left off 1 in the slide set. We don't know why. But anyway, this is example 10 in your text on page 159. 2.5 is zeros of polynomial functions. It says determine the possible number, now I've got to check to make sure, of positive and negative real zeros of this polynomial function. F of x equal 3x cubed minus 5x squared plus 6x minus 4. Okay, positive and negative real zeros. How can we determine how many possible positive and negative real numbers we have, real zeros we have for that? Anyone have a clue? Say again?
3.
One more time. Okay. 3. Okay. Okay. How did you get 3? That's what I'm looking for.
I use power.
Okay. Got what you're answering now. What he is answering is what is the largest possible number of real zeros? That's what you're answering. That's 3 because the maximum exponent is 3. I agree there. Now, there will be 3 complex roots, but we're asking how many real? Up to 3. Okay? But how can I determine how many of those may be positive and how many negative? That's the question I was trying to ask. How do you determine that? Guess? Nah, we can do better than that. How do we determine the possible number of positive? Let's start with positive. Positive real zeros. Second? Okay. I'm not sure I quite understood that. Okay? There is the name of a rule. Hey, we have rules. Somebody's rule of signs. Whose is that? S-I-G-N signs. Ah, right there. Descartes' rule of signs. Oh, yeah. Krista doesn't want to waste any breath. Okay. So, Descartes' rule of signs. How does that work? Anyone know? Please say yes. That you were in presence last Thursday when we talked about this. Are you listening to it on the videos? Okay. What is Descartes' rule of signs? What do you know? How do we use it? Please, somebody. There is here. Come on. Need some help up here. What's Descartes' rule of signs? How do we use it? Anybody? All right. Let's go back a slide. Or two. Right here. If you have a polynomial function, which we do, ours happens to be a cubic. So we start here at a sub 3, x cubed plus a sub 2, x squared plus a sub 1, x to the first plus a sub 0. Exactly what we had on the other slide. It's a polynomial with real coefficients. Ours were all integers, real coefficients. Got it. A sub 0 was not 0. No, it wasn't. I don't remember what it is now, but it wasn't 0. And of course, the a sub 3 was not 0 either. I don't remember what that was, but it wasn't 0 either. Okay? Now, the number of positive real zeros of f is either equal to the number of variations in sign. That's why they call it Descartes' rule of signs. Variations of sign of f of s, or less than that number by an even integer. Okay? So, now, how many possible positive real zeros do we have here? Okay. How did you get that? You go from plus to minus. That's a variation in sign, right? So that's 1. 3, because from minus to plus, another one. And then from plus to minus, another one. 3 possible real zeros of positive real zeros for this function.
I told you 3 first.
Yeah, you said it first, and that's why I said, how did you get that? And then you told me, that's how you got it. So I knew you were answering the wrong question. You answered it correctly, but it was the wrong, right answer for the wrong question, or something like that. Okay, so anyway, we have possible 3. Does that guarantee we have 3? No. Or less by an even number. So it's either 3 or, subtract 2, 1. 3 or 1. Okay. Now, can anyone tell me why we subtract 2? Because if we do have a complex 0 with real coefficients, that means they come in conjugate pairs. Remember? So if you don't have real zeros, if you have one complex, you got to have 2, because they always come in conjugate pairs. So that means you're either going to have 3 positive real zeros or 1 positive real zero. Okay? Now, how can you guarantee a positive real zero, by the way? How can you guarantee me this will have at least 1, period? Anyone know? Let's go to your maximum exponent, 3. What does that tell you about end behavior? Oh, we have to remember that? Huh? Okay, it's odd. What does that tell you about the end behavior? Yes, I can see her doing her calisthenics here. Okay. It starts down here and ends up there. No way for a polynomial which is smooth and continuous, it's going to have to cross the x-axis somewhere. So it's got to have at least 1 real zero. This tells us it's going to be positive real zero. That 1 has got to be positive. Maybe 2 other positive. Okay, so the number of positive real zeros are, let me get my pen set up, 3 or 1 positive real zero. Okay? I don't like to write too much, so I put plus on IVE. Okay? Positive real zero. Okay, how about negative real zeros? How do we determine that? Y'all did read that on the previous slide, how you determine negatives, right? Anyone recall? Second?
Variation in signs.
Okay, but of signs of what? We've already counted variations and signs of this. Ha! We do f of minus x. So instead of x, we plug in a minus x. When we put a minus x here in cubic, what does that do to the sign? It makes it negative because that it changes the sign. So that'll be a minus 3x cubed, because anytime you take a negative number and raise it to an odd power, you change the sign. Anytime you take a positive number, a negative number and raise it to an even power, doesn't change the sign. Okay? So what happens to minus 5x squared? Say again? No, because that's an even exponent. You put a minus x in here, minus x squared is x squared. Minus times minus is positive. So this doesn't change the sign, and it stays minus 5x squared. How about the 6x? What happens if you put a minus x in there? That becomes a minus 6x. And then what happens with the minus 4 if you put a minus x in? It stays the same. Nothing happens. Minus 4. Now we count the variations in sign. And how many variations in sign do we have now? 0. Okay. Now you can almost tell that if you could have had 3 here, and the maximum you can have is 3, you can't possibly have a negative then. If there could be 3 positives, you can't possibly have a negative. So there's 0 negative real roots. Okay. That's all we were required to do for this problem. Okay? Determine how many possible positive real roots, 3 or 1. How many possible negative real roots? Absolutely none. 0 negative real roots. Okay? Now that's all they asked for. They didn't ask for us to find them. Thank you very much. Okay, let's see. I don't think the book finds them, or do they? Don't believe so. Okay? So let me erase what I did. Any questions on this before I erase it? Okay? All right. So the solution, the original polynomial function, that one right there, has 3 time out. Before you do that, you make sure that all the coefficients are real. Okay? They have to be real. And they are. They're all integers. They're real. Good. Then you count the number of variations in sign that you have. And you have a plus to minus is 1, minus a plus is 2, and a plus to minus is 3. So that means you have either 3 or subtract 2, 1 possible positive real zeros. Okay? So that polynomial, then you do the negative of that, out of negative x, and they're actually doing the work. I just talked through it. It's L3 times negative x cubed minus 5 times negative x squared plus 6 times negative x plus, minus 4. Okay? And when you do that, negative x cubed is negative x cubed. So that becomes a negative. Negative x squared is just x squared. So that stays a negative. Negative x times positive, negative, and then the negative 4 stays the same. So you wind up with this, and there are absolutely no variations in signs, meaning there are no possible negative real zeros. None. Okay. Now, so from Descartes' rule of signs, the polynomial function, that one, has either 3 positive real roots, 1 positive real roots, but it has 0 negative real roots. Okay. Now, they did graph it. Okay. And they found out that was at 1. We could have told them that, couldn't we? Because we could have just added our coefficients together here. 3 and 6 is positive 9, negative 5 and negative 4 is negative 9. You know that 1 has to be a real zero. Now, what we didn't know was whether there's 2 more or no more positive real zeros. We do know there's no negative real zeros. None whatsoever. Okay? So, what does that mean for you? Now, let's see. All right. How would we approach this problem if we're trying to find those zeros? They showed us one, and we could have figured that ourselves by just plugging in a 1. But what does that mean to us? What we would have done, the next test we would have used was rational zeros test. And that would have been, look for rational zero, P over Q, and someone tell me what the P and the Q stand for. P is all, yeah, all possible factors of the constant 4, and the Q is all possible factors of the constant 3. Okay? So if we'd have been doing this any other way, we would have said plus or minus what are the possible factors of 4? 1, plus or minus 2, and plus or minus 4. Okay. Amina decided to show today. That's good. All right. Huh?
Good morning.
Good morning. Okay. We would have done that, and what would we have put in the denominator? Plus or minus 1 and plus or minus 3. Okay. But guess what? If we would have done, which we did do, our Descartes' rule of signs first, what could we have left off? The minuses. We know none of them will be negative. So therefore, forget the minus. So we could have just put, on this case, because we knew there were no negative real roots, we could have done 1, 2, 4, and 3. No minuses allowed, because you knew from the Descartes' rule of sign there were no negative real roots. So then you list them, and it would have been 1, 2, 4, 1/3, 2/3, and 4/3. That's all. Don't include the plus or minus there, because you know the minuses don't work. If there was a possibility of 1 minus, yeah, you have to include them all. So you see it does cut down our activity a bit. You don't have to try a negative with synthetic division. It's not going to work, okay? So that's what the Descartes' rule of signs gives us a break there. Eliminate some of the work that we might have to do otherwise. Thank you, Renee Descartes. Okay. So let's move to some other tests. Now, I've already hinted at these before, in fact, told you, but we went over the Descartes' rule of signs too, and nobody remembered. So let's go over this again. Another test for zeros of polynomial function related to the sign pattern in the last row in your synthetic division. Remember, when we have our potential zeros from the rational zeros test, we put them in and try those in synthetic division. And if we get a 0 here, we know that's a 0, right? Okay. Well, now we stop and look at the sign pattern, the last row. Okay? And we don't have to pay attention to it unless that last one's a 0. So given that one's a 0. This test can give you an upper or a lower bound of the real zeros of F. A real number C is an upper bound for the real zeros of F when no zeros are generated greater than C. That's the highest you can get. Similarly, C is a lower bound when no real zeros of F are less than C. Okay, fine. Those are names. What does this mean for us? Here's the rules. We love our rules, don't we? Okay? If f of x is a polynomial with real coefficients and a positive leading coefficient. Here's another little exception here. You have to be leading off with a positive number. Okay? Suppose the f of x is divided by x minus c. Using synthetic division, what's going to go outside the house if you're dividing by x minus c? What goes outside? C, exactly. Okay. Now, if that c, now that c could be either positive or 0. If that c is positive, okay, a positive number, and each number in that last row is either positive or 0, then C is an upper bound. So if you had that list from your irrational zeros test, and you had a 1, 2, 4, 1/3, 2/3, and 4/3, like we did that last problem, okay? If you had that and you tried a 2 in there, which probably would have been our second choice, we would have tried a 1 first and then tried a 2. If we'd have tried the 2 and found that last row down there, and 2 isn't 0, so you're not going to get 0 on the last column there, so you will still investigate, all those would have been positive. As soon as you see that, stop. Say there's nothing beyond 2 will work. 4 won't work. Don't even try it, okay? Because you had all positives down there. But what if that C was a negative number, okay? And the numbers in the last row alternate between positive and negative. 0 entries count as either positive or negative. Then C is a lower bound for the real zeros, okay? And let's imagine we had a plus or minus up here or something, or even if the lowest one was a 1, and we tried 1 there, no, I'm sorry, C has to be negative. So you had some negative value, and you're doing the fractions. Let's just imagine we forgot that we didn't use the Cartwheel sign, so we tried using a -1. So you did a -1, did a synthetic division, and then you would have seen that every other one changed sign. In the bottom row, stop right there. Nothing could be less than -1. That's going to be a lower bound. May not be a 0, but you can't get any lower than that. So that's how we use the upper and lower bound rules. So let's see if we can find, whoa, they skipped example 11. Shame, shame, shame. All right, let's do example 11. Find all the real zeros of f of x is equal to 6x cubed minus 4x squared plus 3x minus 2. Does that look sort of familiar? No, it's not the same one. It looks a little familiar, but it's not the same. Okay? It says find all the real zeros. What would you suggest we do first? And it really doesn't matter the order, but you just need to do them. What's one thing you can do? Anybody? Wake up? Oh, yeah, we could do that. Okay. What could we do? Second? Okay, we could start with the rational zeros test. Okay, let's start there. I said you can start anywhere. I actually like to start with good old Descartes' rule of signs, because that's so easy, right? What does this tell you? Descartes' rule of signs, what does that tell you? Well, surprise, surprise, we haven't seen anything like this before in a week or two, have we? Maybe 5 minutes ago, but not a week or two, okay?
There's possibly 3.
How do you get that? Counting your sign changes. Plus to minus 1, minus to plus 2, plus to minus 3. 3 or 1 positive real zeros. Now notice there, these are real zeros. That means even doing our rational zeros test, and we find some possible rational zeros, those are rational. These real zeros, some of them could be irrational. So we may not ever find them using the rational zeros test. But we know there's at least 1 and possibly 3 positive real zeros. Okay? Now, while we're at it, let's do the rest of it. What would that be? Alpha of minus x, and that would be what? Yeah, none. Minus 6x cubed, because that's an odd power. Minus 4x squared, because that's an even power. You don't change the sign. Odd power, change the sign. That's a 3. And then minus 2, no, 0, negative real zeros. Okay, we got that done. Now, because that doesn't give us anything, I'm going to take that out because it's just taking up room here. I can't get my pen to come up. There it is. Okay. So let me erase this. I'm going to leave the results. So there's no negative real zeros, but let's erase that. So now we're going to go back and take Patel's advice and do the rational zero test. So the rational zeros will be in the form of P over Q. Now, let me back up one moment here. Okay. For Descartes' rule of signs, remember, that can't be zero. I should have pointed that out, and it's not. And certainly that can't be zero, or it wouldn't be a third order. Okay. So, what are the rational zeros? Possibilities. What's P? Plus or minus? Well, we can, you're right. We can leave off the minuses, can't we? Because no negative real zeros. Leave them off. That's the advantage of it. Okay, so it's 1 and 2. Okay, 1 and 2. And how about our denominator? 1, 2, 3, and 6. Okay, so let's list them out. What are the possibilities? 1 and 2. Then 2 over, let's see. 1, okay, 1 over 2 is 1/2. 1/3, and 1/6, and then you do 2 over, okay, 1 over 3 is 1/3. We've already done, wait. Okay, 2 over 1 is 2, 2 over 2 is that, 2 over 3 is 2/3, and 2 over 6 is 1/3. We've already got that. Okay, so those are our possible rational zeros. Now, no guarantee they're going to be 1, because it could be an irrational number for one of those positive or all three. Well, no, only not. There's going to be 1, okay? I can guarantee you that, okay? Yeah, Carla, okay, got it. You're just not sitting in the right place, okay. There you are. All right. Okay. Here's what I was going to say. I can guarantee from this that you got 1 real zero. You know that. But I was going to say they could be irrational. But if you think about what gives you your irrational roots, that would be the quadratic formula. And they come in conjugate pairs. So, yeah, you're going to have 1. Because if you had 1 irrational root, the other one would be 2. And it's not, so we know we're going to have 1. One of those will work. Okay? What's the easiest one to try? 2, you said?
1.
1. Why 1? You can just add your coefficients, right? Because if you put a 1 in here, that's a 1, that's a 1, that's a 1. So this would be plus 9 minus 6, positive 3. Not going to work. You had already done that, right? Okay. Yeah, that's why I went to 2. Yeah, you're right. Okay, so let's try 2 next. Now this one, synthetic division. How does that work? 2 on the outside. What goes on the inside? 6, negative 4, 3, negative 2. Okay, and then you skip a line, draw a line, bring down the 6. Okay, go from there. Say again? 12. 8. What? 16. Duh. Okay. 19. Y'all can do it. I know you can. 38. 36. Guess what this tells us? Nothing beyond 2. That's an upper bound. All of those are positive, upper bound. Well, guess what, team? That's the biggest number out there. So, yeah, that doesn't tell us a lot. Don't use any numbers bigger than 2, but we don't have any numbers bigger than 2. So that may not have been the best choice, but it was the easiest choice. Okay? So let's go back and try something else. 1 doesn't work, 2 doesn't work. So now we get to do the hard part. Okay? And you tell me what you want to put out there. 1/2? Let's do 1/2. Okay? Tell me what to do from there. 1/2 of 6 is 3, negative 1, negative 1/2. Woo! Huh? 5 halves. Right? Because 3 is 6 halves. Right? And minus 1/2 would be 5 halves. Or 2.5, you can think of it that way. And then this will be, yeah, that would be 5/4. And then this would be minus, goodness gracious, 8/4, okay, minus 3/4. Okay, why I even mess with that, I don't know. We certainly can go higher than 1/2 because these aren't all positive, but this definitely isn't 0, so we are going to go higher than 1/2. So what you want to try next? You want to try 1/6. Okay. I was afraid someone was going to say that. Okay. You didn't want to try 1/3 first, huh? She likes to go to the smallest one, so let's do 1/6. Okay? What do we get there? Anybody? 1, negative 3, negative 1/2, and that would be 5 halves again, won't it? And that would be 5/12. Yeah, it's not going to work, is it? But we can go higher because we have change of sign there. So that won't work. Thank you very much. Okay, but it was worth a try. Okay. Okay, he's jumping to 2/3. Okay. Y'all have something against 1/3, I guess, huh? Okay, so let's try 2/3. All right. So what do you get next? Two-thirds times 6. Say again? 4. Excellent. Next. 0. Excellent. Next. 0. Excellent. 3. Someone's looked in the book. Next. 2. And that gives you ding, ding, ding. I thought someone looked in the book. Okay. Yeah, All right. We have a winner. Okay. A winner. Okay. Now, 2 things it tells us. Number 1, it is a 0. 2/3 is a 0. The second thing it tells us is that you don't have any greater than 2/3. Well, we didn't have anything greater than 2, and that's the next biggest one got, so yeah, we don't have anything greater. Now that still means we may have a 1/3 in there, okay? Oh, and one thing I forgot. Ooh, shouldn't have forgotten this. Oh no, this is our first 0, okay? Once you get a 0, you have to try it again to see if it works. But not in this case, because what do you find down here? What does that take? What does that take? What does it take? What does this represent? You have 3 terms as your... Yes, a quadratic. And we'd stop. We don't ever go past 3 because it's so easy to do. What quadratic does that represent? 6x squared plus 3 equals 0. Now, what can you tell me about that statement? You can factor out a 3. I'll agree with that. So factor out a 3, and that leaves you 2x squared plus 1 equals 0. So yeah, that factored. It did. Fine. But what else does it tell you? Even that. No more real zeros. Because anything past this, these are going to be complex, imaginary components, because this is always positive, that's positive, and you can't add 2 positive things together and get 0. Okay? It just won't happen in the real number system. You can in the, well, it won't be positive, you can do that in the complex number system. So, unfortunately, They said find all the real zeros. Oh, that's what they said. Find all the real zeros. We found it. Just one. X equal 2/3. They didn't say find complex zeros. They said find the real zeros. Okay? Now, this is a little interesting because what would be the factor that would represent that? X would be the factor that goes along with that 0. X minus 2/3. And the other factor is 6x squared plus 3. Okay? Now, supposedly if you multiply those together, you should get the original polynomial. And let's just follow it and see. 6x squared times x will give you 6x to the cube. Okay? And when you do minus 2/3 of 6, that would be minus 4x squared. There's your minus 4x squared. When you do x times plus 3, that's plus 3x. There it is. And when you do a minus 2/3 times a positive 3, the 3's divide out or make go to 1, you have a minus 2. Sure enough, that works. So this is one factor. This is an irreducible factor. Okay? Irreducible quadratic in the reals. Okay. Now, another way you could write this, if you chose to, remember we factored out the 3 here? What if we factored the 3 out of that and multiplied here? Then this would have been 3x minus 2, and this would have been a 2x squared plus 1. That would have been an even nicer way to put the factors. Okay? But this is perfectly fine too. That way you just don't have any fractions. I know y'all love your fractions, so you can put it this way if you want to, but if you don't care for them, you can write it that way. Just a couple different ways to write the answer. Okay. You don't have to do what I just did. They didn't in the book. And they did show the graph, and it looks a lot like the previous one, okay? If you were having to graph this, and the same went for this one too, what's another, okay, 1, x equal 2/3. You go on the x-axis between 0 and 1, go 2/3 away, that's a 0 right there. That was easy. What's another easy thing point to plot in that? That was an x-intercept, by the way. It's another really easy thing to plot. If you were graphing it, they didn't ask you to, what would be another thing to do? Really easy to do. What 0? Yeah, but x equals 0. And if x equals 0, y is? Minus 2. Okay, so there's your y-intercept, 0 minus 2. That's always easy. This one up here was 0 minus 4. And if we go back and look at the graph of that one, I was starting to put that out. Oops, it went the wrong way. Look at that. It was heading down that way, and at minus 4, it was going to cross the y-axis right there. Because minus 4 was the y-intercept. Good deal. Any questions on that? There is a checkpoint. Please do the checkpoints as soon as you can after class. Okay. Any questions on these tests? All these tests can help you out, folks. If you have a whole string of those rational zeros, positive, plus and minus, and stuff, as soon as you see that there's no positive real zero, don't try any positive. Or no negative real zero, don't try any negatives, okay? And when you see that you have a whole string of them and you use one and you get all positives for a positive number, don't go any higher, okay? Eliminate those. Throw them away, okay? And if you have a negative you're dividing into and you have alternating signs here, don't go any smaller. Those tests save you time, save you effort. Now, some of you are hard workers. You probably don't care for this, but I'm lazy. I want to save as much effort as possible, okay? So let's look at an application here. You're designing candle making kits. Oh yes, that's what your dream job, right? Each kit contains 25 cubic inches of candle wax. You're given that, okay? and a mold for making a pyramid-shaped candle. A pyramid has a base of something going up, and it's usually a polyhedron base, a triangle, a square, a hexagon, something like that. And then all the sides are going up to one point. That's what we mean by a pyramid-shaped candle. You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. Okay, they finally got around to telling you the base of this pyramid is square. Okay, and then you're coming up to a point like that. That's sort of how it looks. It's a pretty ugly rendition, but you got what it is. Now, what they said, the height of the candle, that would be from the point here to the center down here. This height, let's call it H, is, the height of the candle is equal to be 2 inches less than the length of each side. So let's call this the side. There's a side, there's a side, there's a side, and there's a side. It's a square base, so all 4 sides are the same. So H is equal to S minus 2. 2 inches less than the length of each side of the square base. What should the dimensions of your candle mold be? Now, this is one of these, shame on them. Why did they do this to us? Does anyone happen to know the volume of a pyramid? Okay. 1/3. Okay. The book has it, didn't it? Okay. All right. The book did not have it in the back of the book where they have these, but it's very similar to the volume of a cone. That has a point up there, and that's 1/3 the area of the base times the height. And so ours will be 1/3 the area of the base, which is your S squared, times the height, which is H, which is S minus 2. So the volume of the candle is going to be 1/3 the area of the base, that will be S squared, times S minus 2. That's the height of the candle. That's from the volume of a pyramid is 1/3 the area of the base times the height. Okay? Same thing for a cone. 1/3 the area of the base for a cone. If it's a circular base, pi r squared times the height. But the height is 2 inches less than the length of each side, so S minus 2. It's going to be a really short, squatty candle, but maybe that's what you're looking for. Okay. Now, we also know you have 25 cubic inches of candle wax. So this volume has to equal 25 cubic inches. I'll leave that off. Okay, how would you proceed to solve this problem? Sit so I won't be blocking it any more than I normally will. Can y'all see any better with me sitting down? So how do we do this? Well, this will be, let's multiply through 1/3 of S cubed minus 2S squared, right? You just distribute the S cubed through that, okay, and that's equal to 25. Now, what's messy about that problem? There may be several things, but what's one thing that is? Yes, the fraction, okay? So how do we get rid of the 3 there? Multiply both sides by 3, okay? And this will make it S cubed minus 2S squared is equal to 75. Perfect. Now, what would you do with that? I can't even read that. Okay, there it is. Okay. Subtract 75 from both sides because this is something higher than 1. Any power greater than 1, you want everything on one side, 0 on the other side. So we'll subtract 75 from both sides. That gives us S cubed minus 2S squared minus 75 is equal to 0. So what is our procedure here? We need to find the zeros of that polynomial, right? That's what we need to do. Now, what would be a possible test for us to do to make our life a little easier? Give me one to start with. Say again? Okay, he loves the rational zero test, and it is a lot of fun. But say again?
The man.
The man. Oh, the man. Okay. Good old Descartes, the man. Okay. Yeah, let's use his rule of signs. What does that tell you? One positive real zero. You have one change of sign, so you have one positive real IBE, real zero. And guess what, folks? We're building candles here. Do you think we'll have any candles with negative square bases? I don't even know what that means, okay? So that's what we're looking for, that one positive real zero. So now when we go to Patel's rational zero test, we don't care about any of those negatives, do we? Because you can't build a candle with a negative base, right? So let's use the positives. So that's what I was going to get at. There is one positive real zero. That's the one we want. Okay? So let's now go to Descartes' rule of signs. And your P over Q would be what? What are possible real zeros here? Plus or minus 1. Plus or minus 5, you said? Oh, there's a 3 there too. Plus or minus 3. Plus or minus 5. Plus or minus 15. And plus or minus 25. And plus or minus... But we don't need the minuses. Why am I even writing them down? Let me get back and clean that up. Okay. We don't need those minuses because we don't care about negative bases. We only want positive bases. Okay? So let me write that again. It's plus, I keep saying plus or minus. It's 1, 3, 5, 15, 25, and 75. Right? Okay. What are our denominators? I got the numerators. What's the Q's? 1. Okay, we don't need anything there either. So those are it. Okay, let's try 1 first. Let's just plug in a 1 for S, and you get 1 minus 2 minus 75. That's minus 77 plus 1 would be minus 76. I don't think that's 0, right? So 1 won't work. Don't even bother. So you want to try 3 next? Patel does it, but let's try 3 next. 3 will go into what goes inside the house? 1. Negative 2. 0. Excellent. We're missing a term there. And minus 75. Okay. Skip a line, draw a line. Bring down the 1. Tell me what goes next. 3. 1. 3. 3. 9, that's not going to work, is it? Okay? And that's going to be a negative answer there, right? Negative 66 or something like that. That's good news for us because you do have a sign change there, so keep going up. That isn't an upper bound. So let's go up. What's the next one? 5. So let's try 5. Okay. If I can find my pen again. There it is. Okay, 5. What would that give us? 5. 3. 15. 15. 75. 0. Ding, ding, ding. We have a winner. Okay? X equal 5 is going to be the height. How many positive real zeros do we have? 1. Then we found it. Don't look any further. Don't use 15. Don't use 25. And don't use 75. What's more, look at your signs down here. Okay? They're all positive. 0 counts as positive or negative. So that tells you you won't find any greater. So Descartes' rule of signs says stop there. The upper bound test says stop there. We found it. We don't care about those negatives. We're not going to use them, okay? But we didn't even check to see if we have them, but we do, okay? So we're going to use, stop right there, square base of 5 on the base. Now, it says, what should be the dimensions of your candle mold? Okay, the base should be 5 on the side, S equal 5, so it's a 5 by 5 base with a height of, where is it? It's somewhere here. Did I erase it? It's S minus 2, so that would be 3. The height is equal to 3 inches, by the way. That's your answer. It just got all messed up all over the board here. So let's see how they did. They may be a little neater than me. I don't know. I can't imagine it, but let's try. Okay. First, they tell you the volume of a pyramid is 1/3 the base times the height, which is what I told you too. The base being a square, so that's going to be S squared. They put X squared. I'll put S squared. Where B is the area of the base and height, H is the height. The area of the base is X squared. The height would then be, because right here the height of the candle is 2 inches less than the length of each side, so that's X minus 2. We said S minus 2. And we plug that into the formula here, and we get that 25, which is the volume, is equal to 1/3 X squared. That's the area of the base times X minus 2, which is the height. Okay? First thing to do with that, multiply the 3's to get rid of that 3. So we don't have to mess with fractions. That gives you 75 is equal, and then distribute across here, X cubed minus 2X squared. All right. Now, bring the 75 over to the same side. So that would be 0 is equal to X cubed minus 2X squared minus 75. All right. They went straight to Descartes' rule of sign. Now I see why Patel wanted to do that. No, okay. They said the possible solutions are, rational solutions are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 6. Guess what? Possible rational solutions, we only want a real solution. We want one that makes sense, okay? And the minuses make no sense for the base of a candle. So leave out those, okay? Use synthetic division to test a few, okay? 1 doesn't work. You can just plug that in and see it doesn't work. We tried 3. That didn't work. We tried 5, and sure enough, it did. In this case, it makes sense to test only the positive X values. We already said that. And we found 5 worked. And we also saw that you have all positive numbers here with a positive here. So that means that 5's the greatest one you can use. Okay? So the other 2 solutions give you the quadratic at the bottom here, X squared plus 3X plus 15. Try as you might, you'll not get a real solution with that. Okay? You won't even get a irrational solution, well, a real or, okay. Those are imaginary and can be discarded. Throw them away. By using Descartes' rule of sign, you know they're going to be negative. Well, you can't have them anyway. Okay. You can conclude that the base of the candle mold should be 5 by 5, and the height should be 5 minus 2, which is 3 inches. Got it. Now, before concluding this section, and there is a checkpoint, by the way, to do the checkpoint, here is an additional hint that can help you find the real zeros of polynomial. When the terms of F have a common monomial factor, factor it out before applying any of the tests. Okay? So if you can factor that, a common monomial factor. So if you have this, remember if that is not, if the constant term is a 0, you can't use some of the tests, okay? So factor out the common monomial factor first, then apply the test here. We know x equals 0 is going to be a 0 for that, okay? Use your test on that part, okay? And find the remaining zeros analyzing the cubic factor. How many possible real, positive real zeros will we have? So that one right there, the cubic. Tell me. How many possible positive real zeros for this cubic? 2 or 0. 2 or 0. Okay. So you're either going to have 2 or you're going to have 0. If you find one positive, keep looking because there's going to be another. Okay? And how many, but if you hit that upper bound test and you haven't found it, don't look any further. How many negative real zeros could you have with that? Second? Right? That becomes a minus. That stays a minus. That becomes a minus. That stays a plus. So it'd be minus, 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 plus. Only one change of sign. So you will have one negative real zero. Look for it. Okay? When you get to a negative number that you alternate signs at that last line, stop. It may have been an irrational negative zero. All the Clark's rule of signs tells you positive or negative real zeros. And if your rational numbers don't work. So use all the tools in your belt. We got a whole bunch of tools and we put them in our tool belt. Use them, okay, to do what you need to do. All right, that finishes the section. Finally, let's do the vocabulary. Woo, we're running out of time. The blank blank of blank states that if f of x is a polynomial of degree n greater than 0, then f has at least one 0 in the complex number system. Woo, remember that one way back? It's one of the real key ones. Gauss, I think, came up with it, didn't he? Way back, very first of the section. In fact, it's the first subtopic in the section. Page 152, folks. First subtopic and first thing in the block. The blank blank of blank. Page 152. First subtopic, first block down there. What does that read? You got your finger right on it. The fundamental theorem of algebra, okay, states that if f of x is a polynomial of degree n greater than 0, then f has at least one 0 in the complex number system. Okay, number 2, the blank 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 states that if f of x is a polynomial of degree n greater than 0, then f has precisely n linear factors, f of x equal a sub n times x minus c1, x minus c2 times x minus c3, all the way up where c1, 2, and 3 are complex numbers. Okay? The other was the fundamental theorem of algebra. This is, and it helps do, has precise this many linear factors. Look at the second block on page 152. What's its title? No? On page 152, second block in the page. First one is fundamental theorem of algebra. The second one is? Oh, you don't have a book yet. Okay. Okay. Linear factorization theorem. Okay, that's number 2. Of course, we knew that. Number 3, the test that gives a list of the possible rational zeros of a polynomial function is the blank blank test. Rational zeros test. That's a pretty clear one. Okay, number 4. If a is a plus bi, where b is not equal 0, is a complex zero of a polynomial with real coefficients, then so is its blank, blank, which is a minus bi. What do we call that? How is a minus bi related to a plus bi? Complex conjugate. Complex conjugate. Okay, or conjugate pair, maybe. Okay, number 5. Every polynomial of degree n greater than 0 with real coefficients can be written as the product of blank and blank factors with real coefficients, where the blank factors have no real zeros. Okay, one of those is linear, and one of them is quadratic. The first 2 blanks. The third blank, what goes there? Where the blank factors have no real zeros. The quadratic factor has no real zeros. Okay. Number 6. A quadratic factor that cannot be factored further as a product of linear factors containing real numbers is called, I used the term a little earlier, irreducible over the real number system. If it has only irrational numbers, it's irreducible over the rational number system. Number 7. The theorem that can be used to determine the possible number of positive and negative real zeros of a function is called the man. Okay, the blank blank of blank. Second? Descartes' rule of signs. Okay, number 8. A real number C is a blank bound for the real zeros of F when no real zeros are less than C, and is a blank bound when no real numbers are greater than C. Lower bound, upper bound. All right, homework exercises here. Do any of the odds, 9 through 13, they're all at Calc Chat. 9's at Calc View. Do either 15 or 17, they're both at Calc Chat. Any of the odds, 15 to 27, they're all at Calc Chat. 25's at Calc View. 29 or 31, both at Calc Chat. 29's at Calc View. 33 or 35 at Calc Chat, 37 or 39 at Calc Chat, 41 to 45, you don't have to do those are complex, and you don't need to do the others, they're complex. 51 or 53, they're both at Calc Chat, all the rest of them are, okay, then 61 to 71, they're all at Calc Chat, 69's at Calc View, 73 to 77, they're all at Calc Chat. I'll take it if you want me to, thank you. 79 through 85, they're all at Calc Chat. 83's at Calc View. 87 or 89, they're both at Calc Chat. 91 or 93, they're both at Calc Chat. 95 or 97, they're both at Calc Chat. 99 or 101, both at Calc Chat. And then any of the odds, 103 through 107 or whatever. And then there's the true false. No. Think about doing 109 to 113. Blah, blah, blah. You can do the rest of them. Okay. What you need, folks.
Thursday, but Tuesday we'll be here. We're supposed to turn a quiz in.
So, yeah.
Have we missed a test, too?
Did you do the first test? I think you did. Yeah. You remember Thursday, only 30 minutes of class, so you're not going to miss a whole lot, but listen to it because I'll also tell you where to go for the rest of the class there. Okay. Good deal. Y'all win the games, okay?
Yes, sir.
All right. Yeah.
So Thursday, do I have to come here? Do I have to come here?
It's up to you. I'll be here, but
How much time it takes from here to go there?
I count 30 minutes. I count 30 minutes.
30?
Yeah. If you need to be there earlier,
I
go
need to be
straight
there
there.
at 9.
At 9, yeah. You if you came here, you'd have to turn around right around and leave. So I'd say go straight there.
What about my role?
Okay. Well, what does that matter? It doesn't count
But
for
you
anything.
say from 9 to 12:30 all classes are cancelled.
Uh-huh.
So your class is also cancelled.
Yeah, mine's 8:30 to 9. We still have
But
class.
most 9 to 9:45, so 45 minutes is more than 30 minutes.
So
So
what?
more than 50%, that means
No.
cancelled.
We're going to have as much as we can.
I'm confused with this one.
What's
Like
about?
what's asking?
Yeah, we've had several of those before. What is it? You know, we've had them on just about every test and quiz up to now. It's kind of, yeah, it's just like this one.
So we have to just write.
Right, what you do to get that, make that happen.
Okay.
Yeah, right. Okay.
And here, do we have to like
You have to
factor
account
this
for
one?
everything, yeah.
We have to
You account
factor.
for this, that, and
No, do we
that.
have to factor square?
No, this is in standard form. That should be perfectly fine, just the way it
And here
is.
also, we don't have to factor cube.
No, you don't factor it. You just tell what transformations you make to get from this one to that one. What transformations you make to get from this one to that one.
Oh, so it turns right far.
Yeah, right, stretch, shrinks, flip, reflects, whatever.
it?
Yeah, that's whatever you do. Hey, okay?
not ready to turn in yet, but I'm not sure. Am I answering this correctly?
Graph the function. That says graphic.
Yeah, I have none.
Oh, okay, yeah. That's all you have to do is graph it.
Oh,
Okay.
so I don't have to give you the vertex.
That would be helpful when
That'd be
you're
on the
graphing
graph,
it. Yeah,
yeah.
exactly.
So I'm comparing these two.
Okay. What do you do to this function to get that function? And let's see, you're going to be shifting, right or left, up or down, stretching or shrinking, horizontal, vertical, and reflecting.
So
Those kinds of
my
things.
side says stretches to narrow. Comparing that to.
Okay.
So am I answering it right? And then
Okay. Well,
vertex. Six.
okay. Here's the thing. It's either going to shift. It doesn't have to do all these, but it could shift right or left by how many. It could go up or down by how many. It could stretch or shrink by what factor, and it could reflect. Those are your answers. Things that sound like that. Yeah.
That's it.
What's that? Okay. Yeah, that'd be okay.
And this is the graph.
Fantastic.
So here, this is correct, right?
I can't tell you that.
No, but I just did this
Yeah.
one.
Sounds
So
good.
I put this like 5x plus 34.
Yeah, well,
And
whatever.
I put the remainder.
Yeah, remainder, that's what goes
Yeah.
there. That's the remainder there, right?
So I wrote here remainder equals 205.
Yeah, right.
And here also I wrote like the remainder is
That'll be fine. I won't tell you if it's right or not, but
Yeah, but
that'll be fine.
is
Yeah.
that fine?
Yeah. You want to turn it in?
Yeah.
Okay. You have another?
I guess that was my question too. When I did the synthetic,
Yeah.
I said
That tells you exactly that.
okay.
All right.
Where is my key? So we are done with the second chapter?
What's that?
We are done with second chapter?
No, we're going to do 2.6 next time.
We just did 2 chapters
Huh?
per semester.
Huh?
We just did 2 chapters.
Yeah, we're going to move to 3.
But it's like how many weeks? 3 more weeks.
Yeah, okay. We'll talk it to it.
We
Yeah,
cannot
3
do
is pretty easy.
we do 4.
Huh? 4 is
Jump on
trig.
4. Yeah, good.
No, that's pre-calculus trig. That's the next course.
It's fun. Trigonometry.
What's that?
It's fun.